Well, Stephen, you just finished your keynote here at the Swedish Multicore Day, and you talked about multicore solutions for the embedded space. So what are the specific properties in the embedded space as you see it?
So I think in the embedded space we're actually starting to see a lot of the same problems we've talked about in all the other segments. And one of the interesting things about the embedded space, and particularly where ARM comes from, is that energy and power efficiency has been a huge problem there since day one. So a lot of the work we do in designing processors and software and tools for our systems are really focused on energy efficiency and low power design from the start. And we're now seeing that efficiency requirements spread out into other areas of the electronics industry.
What is dark silicon and how will that affect us?
So dark silicon comes from the fact that Moore's law is continuing in the way that Gordon Moore originally stated it in terms of transistor number, but power and performance are not necessarily scaling at the same rate. So we have a lot of transistors available potentially in the future, but not necessarily the power budget to keep them all running at the same time. So there's a real problem maybe coming up that parts of our die, sets of transistors on our die will not be able to be powered, and we have to find other ways to use those transistors to reduce energy costs and to increase performance.
You also talked a little about your plans on how to move forward from here. Can you say a little bit about that?
So I think something that came out in a lot of the talks today was that heterogeneous multi-core is definitely something to look at for the future, and we're definitely working on research in that area, and also domain-specific accelerators. So trying to reduce some of the key algorithms into hardware and put those on the die so that they execute very efficiently is two of the main ways forward, I think.
Okay, great talk. Thank you so much.
Thank you.